Hello everyone, I'm Wei Dongmei. Now I'm doing my assignment in my course methodology, and I want to show you how to do a simple regression using data. And here is the data. There's the data I collected. So I want to do a study about how the digital includes finance affect the rural residents' income. So I collect data from Hebei Statistical Yearbook and Digital Finance Research Center of Peking University. So this is from Digital Finance Research Center of Peking University, and it's really very famous in China. And the other data is from Hebei Statistical Yearbooks from 2013 to 2022. So in order to show a better result, I made a logarithm of these two variables. So we've got the final dv, and this is the final iv. Now let's put this data into the data. Open this and we can put the data from Excel to data here. Choose this one. And this, we can put the data from Excel to data. And now we can have a look. So it's the data. And when we enter the command, it is better to use the do file. So I will use the do file to show how to do my assignment. So this is the do file I write before. And now I will call out my data. So this is the command use, and this is the root. Okay, we can call all the data. Now let's have a look. So all the data here, and this one is dv, and this one is iv, and I select some variables as my control variables, such as long GDP, and industrial structure, and the loan level, open level, government support, and the machine we used in the agriculture. Okay, moving on next. Now we will do the descriptive statistic. Okay, so this is the command summarized. And if we put this command before this, we will have a result in a file. Let's have a look. Yes, this is the result. Observation, mean, standard deviation, minimum, and maximum. So we have 110 observations. So this is the result. So we can copy the result from here to what we want to use. So I can delete the result before. And then remember to close the file. Okay, now let's set the panel data. So this data are panel data, so we should command this one. And this is city code from here, city code. And this is year. So we can see the result. So we can see the result is very strongly balanced. And now we will do a Houseman test. Houseman test will show us which one we should choose between fixed effect model and random effect model. So this is the command. And this is the fixed effect model command. And this stores the result. And this is a random effect model. So we can have a look. So the result is here, but the result is negative. So it is less than 0. So it means that the data has something wrong. Maybe we can put the control variable into the model. And we can do this. And this is the dway, iway, and these are the control variable. Let's do the Houseman test again. Okay, so here is the result. The p value is 1.7397, greater than 0.05. It means that we should choose the random effect model. Okay, moving on next one, regression. And I will use the fixed effect model and random effect model to do this. This is a result, just have two variables. This is IV, this is dV. We can see that the R squared is almost equal to 1. So the result is really very well. And the F test, we passed the F test, and we can gradually add control variable. So we put the control variable into the regression. So have a look. When we put the control variable into the regression, the result is also very good. So how to distinguish the result? Let's have a look here. This is a coefficient, and they are positive influence, and this is a t, this is a p. If the the smaller the p, the result is better. So we can see that the key IV have a very positive influence on the dV. And if we want to get this result, we can put this A as stop. So we can have a look. We can have the result here. Yeah, this is a regression result. And we can close this. And now we do the random effect model. The random effect model, we use RE. So we can have a look. This is the result. And we can have this one. Yes, so the result is very good. You can see the p value is very small. And we can have a look in the file. So the next one is here. So we can, so significant is very good, long index. And now we will do next one. After we do the regression, and we should do a robustness test. And we can use the first order leg of long index to do the robustness test. So we can have this command. And this is gen means generate. We can let this long index lag equal to the first order of long index. And we can have a look about the data. Yeah, it's here. So this is a new data. And then we use the first order lag of the long index to do the regression. You can see the result. If we use the first order lag of the long index, the result is still significant. And we can use some other variable to replace the long index. For example, we can use this one, long depth. Long depth is one of the dimensions of the digital inclusive finance. So we can have a look if we use another variable. Yeah, the result is significant. So it means that we passed the robustness test. So that's all, everyone. So in this video, we do a descriptive statistics Osman test, easy and simple regression, and robustness test. That's all. Thank you, everyone.